Well, good morning and good afternoon, good evening, regardless of your time zone. We are so glad you're here. And my name is Jeffrey Palermo, and we have,
Hi, I'm Paul from Octopus.
and we're excited to bring you this webinar. Man, we have had such a tremendous response to this webinar. We have just so many people on, and we've appreciate all the people who submitted questions. We've taken the most popular and common questions, and we've compiled our agenda for today. And so today we have the Octopus Deploy and Clear Measure Q&A with myself, Jeffrey Palermo, the Chief Architect of Clear Measure, and Paul Stovall, the founder and CEO of Octopus Deploy. And real quick, before we get started, a sound check. If some of you could just respond in the chat that you can hear the audio loud and clear so that we know we're good to go. All right, awesome. That's a lot of responses. Okay, fantastic. I appreciate it. We just have tons of people on here, Paul. We hope to keep up with the side questions, but feel free to speak amongst yourselves on the chat there. So we have a few logistics to cover right before we jump into the content.
So we have a Slack channel, so you can go to that link to join it, and there's a webinar channel. We'll try and keep an eye on that if anyone has any questions. So feel free to pop them in there. It's a bit easier to respond in line. Once the Zoom call ends, the chat disappears with it. If you ask the questions in Slack and we don't answer them during the webinar, we'll take some time afterwards to go through and answer any questions in threads within Slack. So I hope to see you there.
All right, so here's our agenda, and these are the topics that we're going to go through. And we have a few questions that kind of go and migrate through these topics, but these are the themes from just the questions that we've received and the queries about how to make this happen. And so just by way of introduction, I think most of the people on this call are users of Octopus Deploy, or at least are looking at the trial and are in the process of getting it up and running. By way of introduction, Clear Measure is a DevOps-Centered Software Engineering company specializing in Microsoft and cloud platforms, and we help you create a well-run software factory to better connect with your customers, and that'll enable you to move fast, build smart, run your software with confidence as a team and as a business. And so whether you need a faster, better DevOps process, a modernization of aging software, or jumpstart a new software project, we're your guide to get you through. And unlike custom development shops who sell contractors, hand off code, and create codependency, we help you become self-sufficient, world-class software development organizations that can move fast and get the job done. So we're not a reseller of Octopus Deploy, by the way, or any other product. When we are helping our clients gain a better DevOps capability, we need them to adopt the best products that are available in the market. And when it comes to deployment tools, Octopus Deploy is the best. And we specialize in Microsoft platform custom software, and we've seen every type of systems at our clients, and we have not found one that Octopus Deploy couldn't deploy. And so once the build and deploy pipeline is automated, we continually add in quality control steps. And when the process is the same every time, developers can see quickly when something breaks and they can fix it quickly. So we're here, this theme is talking about the database, and we're going to apply pipeline rules and patterns to the database. And so why don't we get into the first question?
So question one, Jeffrey, why, when it comes to database deployments, why is the database different? And I think the database is different. If you think of this, we've been running this Q&A series for a while. People send questions through, we try and answer them. And we never get through one without a bunch of database related questions. So something is really different about the database. There's 395 people on this call right now, and the number keeps dropping up. So people are really interested in the database specifically. What's so hard about the database?
True. And it's different. The compute components of a software system don't have any state for the most part. For instance, a website, web application, or a Windows service, or an Azure function, they can be destroyed and they can be put back easily. And that's why all the simple, trivial DevOps pipelines you find on YouTube and the quick starts have a website, but they have no database, because the website's the easy part. You're just largely copying files and doing some configuration. Storage components, like a database, must preserve data for years. And whether it's blob or table storage or even a directory structure of files on disk or any type of database, relational or document or otherwise, your deployment has to cope with data that's probably been there since the word DevOps was coined. If you have data before 2010, that's definitely true. And when it comes to software, the data is more likely to be the company asset rather than the code that operates on the data. Some of your data probably existed many years ago in a file cabinet of some sort before your company went through digitization. And at some point, the current applications will be replaced by different ones, but the data will live on and will continue to grow and change. And so, well, test environments are easier to manage by, you can drop and recreate those databases, but you can't do that in UAT, much less production environments. So there are a few factors that are the same and different when designing the right deployment process for a database. Let's look at those. So what we have here is on the left, we have the version unit of software. Then we have a pre-production and a production environment. You can have as many pre-production environments as you want to. But we have the schema, or the structure, is owned by the software system and should be exactly the same in every environment. And it should be stored in the same source control repository as the application that owns it. We'll talk about database-only software systems later. But some of the data is architecturally part of your schema and should be the same across environments. For example, if you have some standard lists that populate drop-down boxes, such as name prefixes like Mr. or Mrs., things like that. And these are the same in every environment, and it doesn't change in production. Some data, the next category of data, is configuration and belongs to the environment itself. So just like some configuration is stored in XML or JSON files and poked in during deployment, some of this configuration is stored as records in a database. Some systems have settings that could easily be stored in a configuration file, but they, for a design decision, they reside in a database table. And in this case, that table is environment-specific configuration. Then the next category of data is administrative data, without which the software doesn't do much. An example of this is a user or customer or account records. With none of these, with no user records, no users would even be able to log in and use any of the software features. So if you don't even have an administrative login, the software just sits there, doesn't do much. And then finally, the rest of the data is what you think of as normal data. It's user data. It's constantly growing, constantly changing as people use the system, and it's very different from environment to environment. So when you have a lot of user data, you can't just drop and recreate it. You're dealing with really important data. So as we look at this a little bit more, when we put an automated deployment pipeline in the mix, we can, let me go back to the previous slide. If you're manually deploying from environment to environment and from database to database, then you're manually putting in and curating configuration data. If you store it in a table, you're manually changing administrative data, and you're preserving the user data. Now, let's put Octopus Deploy in the mix. And what we can do when we have a deployment pipeline tool is we can actually, at deployment time, we can version and push in the configuration data, just like we would push in a setting in an XML file or a JSON file. If we need, something to be in a table, and it's going to be that way, and we know it's going to be that way in pre-production environments and production, we can put it there. Administrative data we can also put there, including credentials that need to be secret, and that limits the amount of environment-specific data to just the user data. And that's really what we need to back up and restore anyway. And so by putting in a deployment pipeline run by Octopus Deploy, it enables us to manage the different types of data across environments and really simplifies the problem set so that we have a chance to have it be a completely automated, unattended deployment. So before we go into the next question, that's a lot of information. And Paul, any commentary on that you'd like to add before we move on? You're muted.
always do that. Talk when I'm muted. No, I think that's beautiful. There was a question about how we handle some of these differences between, say, configuration data that would be different between environments versus the tables, etc. Most of the schema would tend to be the same in every environment, ideally. But then you're going to have some of this configuration data, some of which will live in SQL Server. I'm not sure if we're going to cover that later, or if now's a good time to cover it.
Let's do it. Let's do it now.
Oh, I don't know the answer.
Okay. So some of the you know what, the demo later on might show some of that. So why don't we leave for the demo?
Okay.
All right. So the next question, now that we know the different types of data as we get into how to deploy software, Paul, what's the normal status quo at clients before they've automated their database deployments?
I'll tell you a story. So I worked for a bank prior to starting Octopus, and so the process for doing any kind of deployment there was that we would check the code into source control, builds would produce the binaries, we'd run unit tests, etc. And then those binaries would go into a file share, and it was somebody's job to go and copy those and write some scripts that would push them and distribute them out to a cluster of machines that ran the application. And that person was like always very busy, because they were the only person with production access. So anytime someone had a problem with something in production, they would queue up behind that person and kind of wait for their turn to be able to get some help troubleshooting something in production. And then we had a DBA who looked after the database, and it was kind of the same process. You would take a SQL script. So during a sprint, you would need to make some schema changes. You'd keep some kind of record of them, hopefully, and you would take this SQL file and you would email it over to the DBA. And if you go to the next slide, and the DBA would take that script and load it up into Management Studio or Toad or whatever application they use to connect to the database. Ideally, they select the right database. We had one time where they were running in production when it was only a test deployment. We caught it just before things went really bad. But generally, they'll paste this into Management Studio, and then you watch them. And a lot of people on this call have probably seen this. The DBA will read through this like statement by statement. They'll select a statement. They'll press F5 in Management Studio to run it. They'll check that things are okay. And the reason they're doing this is they need to understand what's going on in this script. And this is often the first time they've looked at it. It's in the middle of a production deployment. The application's offline. Users are angry, and here's the DBA trying to look through this script and read it. And you might have altered it a few times between the test deployments and the production one. And it's been a while, they're not sure, so they just got it from an email again. So they're going to go through this and read it line by line. And the reason they're doing that is, if you think, as developers, our job is to change things. If production doesn't change at all ever, we're kind of not doing our job as developers. DBAs, on the other hand, their goals and their KPIs will tend to be around database uptime and reliability. And so any change is an opportunity for something to go really bad, and they're on the line for it. So you have to understand why they want to do this. But there's kind of two things going on here. One is that the DBA feels a great sense of responsibility for what's happening to the production database. And so they really need to understand what's going on, and they need to be able to give feedback and say, you know what, that you missed a where clause off this delete statement, or you haven't taken into account that there's an index on here that's going to take a really long time to rebuild if we change this. And then there's also the act of running it. And the running it, I would argue, is a really bad time for that review process to be happening. But that tends to be where it happens. And it's a really bad thing to have tightly coupled to one person. So the ideal process, I think, would be, if you think of the way we change code, in code changes, we'll often have pull requests, and developers can review other changes long before they actually go and get deployed somewhere. And we kind of want to do the same with changes to the database. So the DBA should definitely be intimately involved in either the creation of these change scripts or reviewing them, rejecting them, getting them revised, etc. But all of that should happen long before it's time to run it in production. And the process of running it in production, apart from some kind of approval, should be really heavily automated, I think. It's always happened, right? The DBA goes on holidays. No one's even got access. In an enterprise, it could take weeks to even get the access you need to run these changes. You don't want that coupled to a person.
Absolutely.
So that's the status quo outside of what we're going to be talking about today. So maybe you can talk about how to do this better, how to automate this, and how to solve some of those problems.
All right. So I think probably most of the people on this call, whether currently or in their history, really identify with that manual process and having a SQL script that really hasn't been run that many times, and no one trusts that if you run it all together, it's going to even work. So let's talk about what an automated, unattended database actually looks like. And so with an application component, again, we have some files that'll need to be copied and some configuration that needs to be poked into XML or JSON files. And it's a complete overwrite in many cases, and not so with the database. So let's back up and look at the architecture of a proven database deployment process. So you have your Git repository, and there conceptually, you have some things in the Git repository. You have application code, you have database migration scripts, you have a migration tool, and then you may have, to some extent or another, build time user data test sets. And these sets could belong to test suites or whatnot. And so in your continuous integration build, you're going to have some major steps. Now, of course, you're going to clone the Git repository. Every build system starts with that. And then before compilation, because we have a data store, whether it be a document database or a relational database schema like we're dealing with here, because these examples right here are SQL Server relational databases. We need to create an environment, provision an environment for the purposes of running our continuous integration build. Now, this particular process will happen at the build server, whether it be Azure Pipelines or TeamCity that stands right in the front and integrates with Octopus Deploy. But it's important nonetheless to know that we're ready to actually create with Octopack our release candidate package. So we're going to provision our build environment, provision the database for the build environment. So we will execute a migration tool. Now there's a few open source tools, DBUp, Roundhouse, AliasQL, that are free and open source. There's also probably the best commercial tool, Redgate, SQL Change Automation, and they all work in a similar way. We'll touch on in just a second, but we're going to execute that tool, which will then run the series of database migration scripts that are in your Git repository that are versioned with your application. And then we will do compilation of the rest of the source code. And then we will run unit tests and component level integration tests. And those will rely on the database actually being there, because they'll execute code that is actually running queries to and from that database. And in order to run integration tests, it'll have to use the data test set in order to initialize enough data into the database to run some test scenarios. And it's also useful whenever you run your build process locally as a private build. It's also very useful to have that test set left in your local database so that when you hit Control F5 in Visual Studio, the application can actually start up and run. But that's how, that's the basic sequence of steps. And then once those tests pass, we're going to package up our release candidate. Now, to kind of look at a bird's eye view, here is the overall structure of the pipeline, again, for application components and database. And by the way, if you would like, we have a poster, a big size version of this, because I know that there's no way that you're going to read all the text. This is an offer. Just go ahead and put a request in the chat, or reply to the email that you received for the webinar, or put it in Slack, and we'll make sure that you get a copy of that poster, and you can kind of print it out in large paper at your local print shop or put it on the wall, whatnot. But we have a pipeline from Git to our continuous integration build, and then we push the release candidate in package management, whether we use the NuGet server in Azure Artifacts or whether we use Octopus Deploy's NuGet server. And then we have no less than a 3-tier deployment pipeline. We like to call the first environment the TDD environment, where we run full system acceptance tests, and it's completely provisioned from scratch every time, including the database. And then a UAT environment, or a manual test environment, where we preserve data, and then a production environment where we also preserve data. That's the bird's eye view, but let's kind of dive in to just a piece of it. So the steps here are for the first line test environment. This is a no humans allowed environment. So from a database perspective, we are going to recreate the database from scratch. We are not going to preserve anything else because that environment exists for automated tests. Automated test suites need to essentially have a known starting state whenever they run tests that rely on data. And so we have to put the data there. And so this is also the first opportunity to make sure that our entire application, which includes a relational database, is deployable. And so we deploy, recreate the database, and if it's there in that environment, we drop it, recreate the database, initialize the database with the non-user data elements that need to be there, configuration, administrative data, things like that. And then we deploy the application. And then with a fully deployed application, including its database, we run full system acceptance tests. And these tests could be Selenium. They could use another testing tool, but it's end-to-end tests. And then once it's done, the next build coming down the line is going to completely trash that environment and restart it and recreate everything. Of course, UAT environments, we need to preserve that data. So what we do there is we migrate the database schema using the same release candidate. By the way, one thing, whether it's an application or a database, we run our continuous integration build once, we build once and deploy many. We build once, we create release candidate packages, put them in the NuGet server, and then we deploy those versioned packages across a number of environments. We don't run the build over again for UAT. So that's just that, whether it's a database or an application, that's kind of how it goes. So that's an important environment difference when it comes to the database. We drop and recreate a database from scratch in that first line TDD or test automation environment, but we only migrate the rest of the environment. So if we look at how that happens from a sequencing perspective, we have a NuGet package for every deployable application component. So if we had a website, we might have website.4.1.231.0.nupkeg. And yes, it's nupkeg. That's how we pronounce it. But anyway, we have our database component, and inside is, and we'll show you just in a minute, the format of the migration scripts. But Octopus Deploy is going to pull that NuGet package and essentially is going to drop and recreate the database. It's going to re-provision the database from the scripts in that NuGet package, and then is going to migrate the schema, bring it up to speed, and then load any user data test sets. And so again, for the TDD environment, we drop and recreate and always load the data. For the UAT environment, we don't drop and recreate it. We run new schema changes only. And then on demand, we have the capability to reload a test set of data. But of course, that's only necessary when our organization needs that data to be reset. And then in production, we only run new schema changes. But everything for all of the environments comes from the same NuGet package that was created at build time. And this is how it looks in Octopus Deploy. Pretty simple. We're just grabbing the NuGet package. It's being exploded on disk by Octopus Deploy, and then we can run our chosen tool using PowerShell that resides inside the deploy.ps1 or post-deploy.ps1 file, making use of all of the variables that are automatically available inside the PowerShell. And then if we're in the TDD environment, we can optionally initialize the database with a set of test data. All right, and then that's a lot of stuff, and there are some rules for migration scripts. But Paul, your organization actually created currently the most popular open source database schema migration tool, DBUp.
Yeah, DBUp came from us, and we use it in Octopus. So Octopus has a database behind it, a SQL database, and so DBUp is used for that. We open sourced it. We use it for our website and a bunch of other things too. All of these tools work the same way though. Any of these migration-based approaches, the way they work is you have a sequential set of scripts that get run. They get run in that order. They're numbered in some way that they sort nicely on the file system, etc. And you need some way to track which ones you've run. And as long as you've got those two things, you've then got a way to, every time you've got a set of scripts, no matter how old or new the database is that you're running them against, it's going to know which ones to run based on which ones haven't already been run. Keeping track of which ones have been run, there's a lot of different philosophies. I think Redgate have a tool that creates I think it might be a view or a stored procedure that just returns or function, I think, that returns the number of the script that ran last. DBUp keeps a table and it keeps a record of which scripts have been run. It's a nice little change log. The great thing about all of these approaches obviously is it's stored within the database, so you don't lose that information. If you back up and restore the database, when you restore it, you will have the old schema, the old data, as well as the change log of which scripts have been run. So there's a few rules for this to work though. The first is that they have to be scripted. So every change that you make, it goes in a script, a SQL file. When you're making these in Management Studio, if you use the designer or something to edit it, there's always a way to export a script and you can just copy and paste that in. If you're not familiar with T-SQL, it can look a little bit scary and it capitalizes everything and it adds all this brackets and stuff that aren't always needed. But SQL is a brilliant DSL for working with databases, and so take that stuff, put it in a script. The second thing is source control it, just like you source control the code that makes up your application. And if you don't do that, you're in for a world of pain. It's the same thing for the database. It must be in source control. Number them sequentially. The sequential numbering is important. It can get a bit messy if you're doing a lot of branching and merging. One of the tricks that we use, you can see in the screenshot off to the right, they're all numbered sequentially, but then they have some text at the end. And so if you've got two branches, you may have two branches and both of them have, script number 12, but then they'll have typically something different at the end, adding this table versus adding an index or something. And so when you merge those back together, it doesn't really matter if there's two duplicate numbers in there, as long as when they alphabetically sort, it's deterministic, right? So it doesn't matter. So it'll just work through top to bottom running these things. The other part is they must be immutable. So what this means is that once you've made one of these changes and committed it to source control, never ever change it. The reason you can't change it is that someone may have run that script against a test database or their local dev database. Maybe they were reviewing your pull request, they ran it down, they pulled it down, they ran it. Now their database is going to say that that script has run. If you change that script, unless you're kind of fixing a bug in the logic of it, like it had some kind of issue that was going to be really slow and you fixed that up, but otherwise, like materially it's doing the same thing, you're going to end up in this inconsistent thing. And the whole thing we're trying to fix here is that everything should be consistent. You shouldn't be surprised that there's this extra table or this extra index in production that is cropped up. It should be the same across all the environments. Write them at dev time. This is our tip. There's two ways teams kind of do this. One is they'll spend like 2 weeks doing work in a sprint, and at the very end they craft a migration script. What happens there is that you've forgotten a lot of the reason behind why you made a schema change, and so you may have forgotten some of the changes you need to make to move data from one part of the schema to another. So for example, you've added a column, but you don't want to forget the fact that you need to populate that column, and it might come from a sensible default based on some other table you've got. When you're in dev time building that feature, you're adding this new screen with a new text box or something, or you're adding somewhere in the app that's going to display this, you'll know what the sensible default is. If you write that migration script at the same time, chances are you'll remember what that should be. And the other thing is this makes it sure that every time your devs are getting the code from source control and they're running this set of schema changes, they're testing the script right then. The whole philosophy behind Octopus is that we have the same deployment process for every environment you go to as much as possible. So when you go to production for that first time in a few weeks, that exact process has run in the test environments 5 or 6 times. It's run on the dev environments. And we want to do the same with the SQL scripts. By the time that migration script runs in production, that should be the 15th time it's run. It should have run 14 other times successfully in all these other environments and on dev workstations prior to production. And the last part is same migration scripts for every environment, as much as possible. Even when you use Azure SQL Database, you've probably done this where it makes suggestions on what kind of indexes you should have based on usage. and it'll generate like the index thing and there's an easy button to apply it. Don't do that. Take the script that it generates, put it into one of these change scripts, check it into source control. And now if you ever do find yourself having to rebuild production or wondering why something's running really slow in test, it doesn't seem to be a problem in production, you're making sure you've got that consistent flow between the environments. So those are our rules for successfully doing this migration script approach. DBUp kind of embodies this philosophy, Flyway, Roundhouse, AliSQL, a bunch of other tools. They all work the same way. Just pick a tool that works for you.
Yeah, I think this approach from an algorithm perspective started being piloted around the agile community, agile and extreme programming community, probably around 2005, 2006 timeframe, when continuous integration was really being talked about, and the algorithm of storing discrete migration files in source code meant that you could go back in time to 2 weeks ago, and guess what? 2 weeks ago, a number of these files would not have existed. And so running the files that were there 2 weeks ago, you come out with exactly the schema that was the right one for the application as of 2 weeks ago. And it guarantees to get any target database up to that version because of that history table that exists in the target database. So from a mathematical proof perspective, this algorithm is proven, regardless of what tool you happen to choose, because there's a number of tools now that essentially use the same algorithm, but it's proven now as an approach, as an architectural approach for database deployments. And it's also friendly to feature branching. Your numbering scheme is, if you're going to do feature branching, you either need to collaborate and say, hey, I'm going to take number 12, number 13, or some people have resorted to putting a timestamp in there as well, just to make sure that they're sequenced properly. But when you're pulling in an SQL file in a pull request, guess what? That's part of the pull request. And so it can be tested in advance of the merge back into master. So this is a proven algorithm, regardless of what tool that you happen to choose. I think this is the algorithm to go with when deploying your database. All right. Now, I think we had some comments in the chat as well. What about DACPack or SQL source control or the other state-based methods? How do these differ from the migration script approach?
Yeah, and someone just asked in chat too, what's the disadvantage of the migration approach that we just talked about? The only disadvantage I know of is that sometimes people don't like SQL. And so they like to be able to go into designer tools, etc., add columns, add indexes, and not worry too much about the SQL that's being generated under the hood. But it comes back to this thing of the database being fundamentally different. So DACPack, SQL source control, the database projects that you create within Visual Studio, they take a slightly different approach. So over there, you'll have sort of a state-based system. So instead of migrations, say, migrations are all about how to get from one state to another. If you look at a migration script, it's not very clear what the current table structure looks like, because you'll have script number 1 creates the table, script number 5 adds an index, script number 7 adds a column, script number 8 adds a default, script number 9 drops a column. There's nothing you can really look at in those scripts to understand what the table should look like when it runs. Of course, just run them and then go and look in the database that's created as a result, and you'll see what the schema looks like. The database projects and these other approaches, the approach they take though is they'll say, here's a table, and here's the columns you have, and here's the indexes. And when you change them, it just updates that one file. And then at runtime, what will happen is that it'll compare the two databases and figure out what the differences are. So if you've ever used Redgate SQL Compare to compare two different database schemas, it'll highlight all the differences. This database has a column. People do this sometimes when they inherit a production database that they realize is not quite in sync with the test databases. And so this is kind of taking that approach, but then generating a script and running that. Now, those tools, they work really nicely in one respect, which is that you've got that file that explains what columns, etc., make up this table. And when you merge a change to a schema, it looks really nice because your pull request is just a merge that adds an extra column or something to that definition. The downside to that approach, though, is that this whole tool is going to work by comparing these two different databases, generating a change script and running it. And sometimes that's wrong, because if you take the classic example is you've got first name and last name, and you've got a full name column and you've decided to make first name, last name. From a schema change perspective, you're dropping full name and you're adding first name, last name. From a data perspective, you've just lost all of your customers' names. So what you want to do is you want to create the full name column, and you want to create the first name, last name column, give them empty default values, then do an update script that somehow splits out the full name into first names, last names. Now, one of the rules, this is a bad example because one of the rules of naming humans is that there's actually no consistent naming scheme that humans follow. And so that's why we try and just use full name for things. But this is an example, though, of where intrinsically, when you're changing the schema, there is something that needs to happen to that data. And at development time, you're probably very aware of this. When it's time to run it in production, you've probably forgotten, because it was 2 weeks ago during a sprint that you added this change to the columns. And now you've got this tool and it generates and it says, oh, here's a bunch of changes, perhaps a really long script because there's a lot of changes that happen during that sprint. And you gloss over the fact that you've just deleted some really important data. This approach does work if you're comparing the two databases and generating a change script, but only doing it at kind of dev test time, and then taking that change script, thinking about what other changes you need to make, doing those manually, etc., and then taking that script and then following the migration approach. That's the only time we really recommend these tools. Another disadvantage someone pointed out in the chat, which is very true, is that these approaches are slow over time. So once you get a really big database, the migration script is great because when it's time to do a deployment, it very quickly works out which scripts haven't been run and then just runs the 3 or 4 that need to. So when you're deploying to a test environment, you deployed to it 10 minutes ago, there's only one schema change, it runs one file. When you go to production, there might be 5 or 6 that haven't been run, so it just runs those 5 or 6. But it's not trying to run all 1,000 of them, after a few years of development. Like Octopus, I think we've got probably about 150, 200 of these change scripts now, and they can take time to run from start to finish. But that's only when you're creating a new database for the first time. And there's a bunch of tricks you can do around kind of baselining if you ever need to as well. And so whereas this compare-based approach actually gets slower because the bigger the database gets, the more objects are in it, the longer it takes to do these comparisons. There's that story of Schlemel, the painter, he gets a job of painting the roads. And on the first day, he paints a mile. And then on the second day, he paints half a mile. And the third day, he paints a third of a mile. And people say, why are you getting slow? And he says, well, I'm getting further and further away from the paint can. And this is the same kind of algorithm that happens with this comparison-based approach, because the database gets bigger over time. It takes longer to compare.
Yeah. In the chat, some people were asking about performance and slowness and advantages and disadvantages. When we're talking about very large databases, there's nothing that's just going to take a couple seconds. So when we're talking about large databases, I mean, we all know things take time. It takes time to process. And what we're doing here from a DevOps perspective is giving our teams the ability to provision a new SQL Server database from what's in source control. And if that's not a part of the deployment pipeline, then we don't even have the ability to provision a new database, or it takes hours and it's a manual approach. And so it's for big databases, big schemas, it's going to take a little bit of time. Now, on the migration approach, someone brought up the good point that someone who's clearly using migrations for a long time, you have dozens and dozens, and once you get up to over 100 of these migration scripts, you're just running through one at a time. You can re-baseline. We say the rule is don't ever change it. Now, the consequences of if you change it are you are not going to go back in, you're not going to be able to go back in time. So as you look at your pre-production environments and your production environments, even if you have a tenanted, multi-customer implementation, you have lots of production environments, one per customer perhaps, or a shard database, look at the oldest version of the database that you have out in any of those environments. And then any change script before your oldest version can be safely compacted into a single rebaselining script without losing anything. Because then when you go to deploy the next change, you're still only deploying one new script or two new scripts, but it can speed up the development experience because now you've taken probably 100 scripts and compacted them into one, and then you can do a little refactoring. If you added a table at some point and then removed it at another point, you can go and just consider that a no op and just take it out. So that's the rule when rebaselining. If you go and look at the oldest database environment that you have out in the wild, and then you can rebaseline and compact the scripts that existed before that version without any consequence. All right.
And Johnny in the chat asked a good question that there are tools that support essentially a hybrid approach to this. So in Flyway, for example, you can have a whole bunch of migration scripts and then a bunch of scripts that are sort of that run every time. And those are really great for things like stored procedures, views, functions, things where you don't really care too much about what the history was. They do get dropped and over. It's like the reason why we're talking about most of this is the reason we need the migrations is you can't just drop a table and recreate it every time you need to change something because you lose all the data. That's not the case for stored procedures, functions, and a lot of these other programmable objects in the database. So Flyway has these kind of two approaches. And the reason why that's nice is if you just have the migration scripts, the linear set of sequential scripts we showed, you have to kind of go through each one to work out where that stored procedure is defined. And then when you're creating a new version of that stored procedure, maybe you're only adding one line to a large procedure, you're going to paste that whole thing back into another script anyway that gets run as another migration script. It's nicer and it merges a little bit better if you have those in a separate folder that just run every time. The downside is you kind of end up dropping and rerunning these procedures. And there are some cases where indexes could kind of follow the same thing, but it's a bad idea. You really don't want to drop and recreate an index just for the sake of it. So those work much better in migration scripts. Things like views, you can generally drop and recreate very quickly without too many problems. The downside to that, though, is it doesn't know which ones are run unless it kind of takes a hash or something of the definition of that object and remembers it. So DBUp has some support for this, so does Flyway, and I'm sure the others do too.
Yeah, and those details, I don't think there's any hard and fast rules. We've seen them be those are more details of how you might choose to organize it, but the ability to have the entire schema in your Git repository and then in your build process have a build time database that your integration test can run against, and then be able to provision new databases in pre-production environments. That ability, that's the huge part. The details about, oh, should we put stored procedures in a migration script or in an anytime script, or what, you as a team can make those decisions and kind of change those, because those are more of the smaller decisions that you as a team can decide. But just implementing this architecture gives that huge DevOps capability on the database side. Paul, before we go into this next question, there is one scenario where a compare based approach does make sense, and it's probably a better solution, whether it be with Redgate SQL source control or DACPack. And that is when you have a legacy database which was not designed with automation in mind, and especially when you have customer shard databases where you have dozens, and in some cases maybe hundreds of individual shard databases, one per customer, and they were intended originally to be the exact same schema, but for one reason or another, because manual deployments and whatnot, over time the customer specific shard databases have cropped up some small customizations, and regardless, they're differences. So instead of having dozens or a few hundred of exactly the same schema, you have dozens or a few hundred of databases which have little changes, and they're quite custom.
Yeah, so we have that problem with Octopus. And so if you think, when we ship a new build of Octopus, people go to the website, they download it, and they install it locally, and they set up their own database for it. And this happens, for some customers, they might have a particular weird thing they do around a lot of objects of a particular type that no one else has. And so we might suggest to them, or they may discover themselves by looking at the query plans or something, that there's an index that they should add that we think doesn't make sense for everybody to have, but they put on their own database. It's not common for them to create their own columns or extra tables or procedures or anything, but they may make a view or something that allows them to do some reporting of stuff that's in our database. Mostly indexes are the main thing. And so we have this problem of like a release goes out and it's now going to get downloaded and run on thousands of customer databases, which all could be a little bit different. The migration approach still works really well for that, because our migrations will just say, we do have something that will scan for any extra indexes that the customer might have created that could break things, and we'll suggest dropping them if they encounter a problem with doing this upgrade. But then what we'll do is our migration script will say, add this column, add this table, do whatever it's doing, and we can just assume that that will run across all of those databases. And if it doesn't, we'll pick up the problem. The other great thing about the migration script approach is it doesn't matter how long it's been since you updated, because if there are 20 scripts and on one database only one of them hasn't been run, it'll run that one. If it's been a really long time since this customer upgraded, it might run 10 of them. But whatever it is, you end up in that same consistent state. Practicality-wise, that's worked really well for us. I'm not sure how much I would trust wanting to do that comparison approach against all of these databases, and if there's some kind of conflict or data loss, trying to manage that through remote support with all of these customers.
Right. But the key with the DevOps pipeline is you are doing the same process over and over and over again. So regardless of what you choose, you gotta have it completely automated and unattended and tested over and over and over again so you can trust it.
Now, the example you gave, though, of you've got this legacy database that was done prior to doing all these migrations, and someone asked too about this baselining thing I touched on. So what you do there is you've got this database. It's been around for 10 years. It's got heaps of tables, all of this kind of stuff. You go into Management Studio or one of these comparison tools, and you have them generate a script that defines, here's exactly how this database looks. And now you've got a script that at least is like the very first version of your migration script. So you can go from an empty database to having a database that looks exactly like the one you want it to look like. Then the next step is that you go to those old databases, and we talked about how we track which scripts have been run. You just insert a line that says that V1 migration script has already run against this database. So you kind of lie in those existing production lines to say that the baseline script has been run. But now you can then go ahead and do those sequential versioning scripts for every other change you make, and it will run consistently between the different databases.
Yeah, good point. All right.
So Jeffrey, when a deployment fails, how do you configure a rollback? And a lot of people are asking this in the chat too.
Yeah, because with database, there's big consequences for when a deployment fails if the system's offline and things aren't working properly. So the main point, unfortunately, a rollback is a failure, and nothing in continuous delivery is designed to go backward. And when you have an automated deployment process that just unexpectedly failed, are you really going to trust the same process to then reliably perform an automated rollback? And most of us wouldn't. And so we need to make our deployments a series of very small changes that may have each been tested thoroughly. And that way, we are never making big changes, but just many very small changes in sequence. And let's discuss some common scenarios. For example, if we were splitting a phone number field, most phone numbers are delimited in a reliable way. If we're splitting a phone number field on a database, and we're pulling out a country code and an area code and putting them into separate columns, and then we're removing the original phone number field. Once that field has been removed, once data has been destroyed, there's no way to roll back. The only rollback is a database restore to put that data back. Now, you could say, you know what, I could create a script to recreate that data, but essentially you're just recreating fresh data. You're not actually rolling back. So we can create compatibility shims in your shared state in your database that's compatible with multiple versions, and then you can redeploy the old version upon failure. That's a two-stage deploy. And while your DevOps pipeline is still rolling forward, it's still deploying forward, you architecturally create a two-stage pattern that delays the destruction activity until a period of time where you feel comfortable that everything's good. So step one is you modify the database with the new and the old schema compatibility, meaning you add the new columns, but you don't remove the old ones. Step 2 is deploy an application. Step 3 is, step 2 is you deploy the database down the line all the way to production. Step 3 is you modify the application to rely on the new schema, the new columns. Step 4 is you deploy again, and now the new application is in production. Step 5 is to modify the database to remove the old schema elements and then deploy that out to production. So it's so important to have all 3 of the types of environments in your pipeline so that your deployment is well practiced before the production deployment. Because deployment failures should be a very rare occasion, and thoroughly postmortemed when they do occur, even in pre-production environments. It's very expensive to design a continuous delivery value stream that actually permits going backwards at any time on a whim. And we rarely see, or really never see, that capability provide a return on investment. Like Paul mentioned before, there's some tools that are designed to inspect the target database and decide on the fly the right thing to do. But because you're in the middle of a failure scenario, we're in uncharted territory. Don't rely on a quote down migration or a compare process to automate this for you. Design your deployment pipeline to fail on pre-production environments so that the exact set of scripts being run on production have been run on several environments prior many times. And even with .NET Core, with the Entity Framework, the built-in migration tool there has a down script, and it does have a compare-based capability. But unless you're going to be rigorous about testing all of the permutations of rollback or go down scenarios, you're going to have something that when the time comes and you have an unexpected failure, you're going to then rely on something that really hasn't been tested and is not going to put Humpty Dumpty back together again.
Yeah, the question of those down scripts came up into the chat too, and I think the same thing. Down scripts don't work for 2 reasons. The first is that if you could predict what was about to go wrong in the production deployment, you probably would have just fixed that and not spent a lot of time writing the down scripts. And so every time we've had them, and there's been a situation where that could have helped, it turns out it hasn't, because we didn't really predict what it is. The other part is the temporal aspect to all of this. So when you a common approach people take is they'll back up their database, and then they assume that if something goes wrong during the deployment, they will just roll back to that backup. But often deployments succeed, and what you've deployed is the bad thing. So you've deployed an app that had a bug in it or something like that, and you don't discover this until weeks later. In the meantime, people have been putting data into the app, they've been using it. You're not going to go and restore a 2-week-old backup or a week-old backup and lose all that data that you've just collected from customers. And so there's kind of a period of time of like 5 minutes after a deployment where just rolling back to the backup you made is the rollback strategy. From then on, once real user data starts coming into the system again, the rollback strategy is call your DBA and figure out how to get to the state you need to get back to, drop the objects, whatever it is, and hopefully do some of those things in a migration script if you need to. But the idea that you can predict all those things that are going to go wrong at dev time, or you would have just not had the problems in the first place if you could predict that.
Yeah, someone in the chat made a good point. When you have all of the components, including the database, integrated in your automated DevOps pipeline, you have the ability to do a really short cycle time on a hotfix. So you can quickly make a change and get it back out and essentially recover by deploying forward.
Yeah. And someone brought up that rolling back stored procedures, views, etc. That is a common thing, and you would just drop them or revert to the previous version. You don't want to do that with a database backup though, because restoring a database backup can take forever. You also lose data. That kind of stuff, you're going to just go and find the old version of that script and rerun it. But again, you're only doing that because you didn't predict what was going to cause you to have to do that in the first place. So you're not going to be able to automate that.
Right. And we touched on this a little bit, but Paul, how do I configure a 0 downtime deployment when the database and application components both need to change?
Yeah, so you're getting this weird thing, don't you, where you're making a schema change and you've got application code that relies on that schema change being there. And which of those do you deploy first? Do you deploy the app that relies on the new schema, but it's going to break because it's going to query the table and find it's not there? Or do you deploy the new schema and have the old app that's still running break because it doesn't understand this new column that got returned? So there's a few things you can do, and a lot of them depend on the kind of change that you're making. The most common approach is people just take the application offline for the few minutes while they're running these scripts, but that's obviously not a zero downtime deployment. So to get to zero downtime, which is often very important when you've got an application that runs across multiple servers, like that have a cluster or something running them, is going to be always a two-stage approach. So the first stage is going to be to make the schema changes in a non-destructive way. So you might be adding a column, adding some good default values, adding an extra table, something like that. It shouldn't break existing code, and you want to test that. So you want to test as part of your kind of build out process, the idea that you can run this migration script and then run the old version of the app against it, and all the workflows still work and it's not encountering problems. Part of that is, if you have an ORM that kind of complains when an extra column comes back that it wasn't expecting, making sure that those kind of things don't break if the old app is getting something from a newer version of the schema. Once you've kind of solved those problems, you're gonna make this change in a non-destructive way. Then you can put the new application in, and it's going to be able to read from that old part of the schema. Now, some changes you need to make are going to be destructive. So you're adding a column or you're adding a table, and then you need to kind of drop the old stuff. You're going to have to do that as part of another release. So for some period of time, you're going to have an app that's going to be kind of understanding this, let's say this messy version of the schema, because it's going to have redundant data, etc. And then after that, you're going to make a new release, which is able to work with both of those. This is a problem we actually have in Octopus at the moment, because if you have Octopus server running over a cluster, all sharing the same database, at the moment you have to bring that cluster down, and then we make all the database changes, and then we bring the whole thing back online. We're finding for more and more customers, they have hundreds of developers using Octopus. They don't want that downtime. We need to start incorporating this as part of our strategy, and that's the way that we'll be doing it.
Yeah, good point. Good point.
Someone asked about, could you use a shadow database or, set up a blue-green version of the database? The trouble with that is you're going to have the app writing to this old database or this temporary database, putting data in there. Then you're going to make the migration scripts over in a new database. You're going to get the app running, pointing at that new database. Now you've got to get the data from that old database into the new one, and you're going to have to write some migration scripts to massage it into the new process. It doesn't work, in our experience, very well. So Jeffrey, we've talked a lot. Do we have a demo or something that shows what this actually looks like?
Yeah. So let's go over to Visual Studio. I mean, Paul, out of coincidence, I just happen to have Visual Studio right behind the slides. Look at that. So I just ran the private build script, which happens to be a Saki build script. This is an application that's probably been around for 5 years. It's a training application, so I can show every bit of it. It's called Clear Measure Bootcamp, and for about 4 years of that, it's used AliSQL, which is one of the tools that just runs SQL files in a sequence. And if I show what those scripts look like over in Solution Explorer to the right, this is a Saki build script, and so you can see I'm dropping the database clearmeasure.bootcamp, and then I'm executing all of these. So locally, I have a local database, and it's so important that every developer has a local database. Get away from that shared development database. Every developer needs their own SQL Server playground, whether it be on the local machine or somewhere else. You just need a dedicated one. So this actual application was originally developed with an in Hibernate object relational mapper layer, and then it's been brought up to .NET 4.6.1 and has Entity Framework Core 2 applied to it, because it's now at Net Standard 2. So that's the version where .NET Framework applications can use .NET Core libraries, and so you can see that here where the names, schema modifications for EF Core 2 cutover, because there are actually some consequences there. But that's what it looks like. Now, that is AliasQL. We've also have a new database project because this application has been converted to Redgate SQL Change Automation, which is a commercial tool that uses the same strategy. And so we have a baseline script that actually has all of the database schema changes that have been previously executed. And then we have one migration script that's happened since the conversion. And that's basically dropping the previous history table that the AliasQL tool happened to use. Now, the developer workflow, if I were to need to modify the employee table I have over here, is now you'd want to go through a test-driven development scenario. So, we'd want to modify our integration test that actually verifies that persistence works through our data access layer and I'm going to create a nickname property on the employee object. And so, you want to modify your entity framework core mapping and go ahead and add the nickname line here. But then those tests would fail, and you just come over here, right here in Visual Studio, and put nickname, and we'll just leave the data type at the defaults. And then I'm going to go ahead and click the button. The Redgate tool just actually executes schema compare under the covers, generate script. And in this workflow, you don't even have to generate the script yourself. You see over on the right, the script has automatically been time-stamped so that it sequentially is in the right order. And then we see we're adding a nickname to the employee. Now, we need to initialize that. So we still need to customize it. The tool is not going to be able to do everything on its own. And so we still need to customize it. And what that means is if we were to initialize it, let me just paste in some sample code over here. This is common. You update employee and set the nickname to first name plus last name. And that way we don't have a null column. And as people go and set their nickname, they can do it. And that's that. So all we have to do is deploy the project, or we can just run the script and it'll run locally. And then when we save everything, if I go to, actually, I don't want to save it as a separate file, but because it's here, when I go to the whatever Git tool I'm using and look at changes, see, I have that new file here. So when I commit back to my Git repository, essentially I have the changes and it's going to be committed. And then the developers who are on my team are going to receive my change whenever they pull in and run their build, and they're going to get the new nickname column. So that's essentially the developer experience. SQL Change Automation kind of automatically helps you do that. Whereas the other tools, you're just going to have to write the tools yourself and a few more steps, but it all works the same way at deployment time. And I think we've already gone over that. So that's essentially the demo. And it really is as simple as that. I mean, I know there's a few moving parts, but it integrates with the continuous integration build seamlessly, the Octopus deployment pipeline seamlessly, and once it's in place, every developer that we helped get this in place absolutely loves the experience.
Very nice. I think we're at our time mark. So if you have any other questions, we'll stick around in the Slack chat that's linked at the bottom. We've tried to answer some questions that have come in through the Zoom chat too, but once the Zoom call ends, we'll probably lose that chat or the chance to reply. So if you do have any lingering questions, feel free to jump over to that webinar channel in the Slack link at the bottom and ask them there, and we'll stick around. Well, I'll stick around at least. I'm not sure if you are for another hour or so, and we'll ask and we'll answer any questions.
Well, the one thing that we did that we'll do again this time from the last Q&A last quarter was any of the questions. A lot of them we published as blog posts along with answering them. So we'll make sure that all of the questions get answered, even if it takes us a while. But there's one question, if you don't mind me answering it here before we end, that actually got asked several times, and that is, what if I have lots of applications that are all referencing my database, and my database connection string is kind of all over the place throughout the company? And that's a good question. when architecturally, when you look at your enterprise architecture, you have to ask yourself where your system boundaries are, and what is a distinct application and what is a mere component of an application, because what you put in a Git repository is going to be versioned as a unit, packaged up, and then deployed as a unit. And so in some cases where you have a big long-time database that's used by, I think, 10 other applications by various departments, from an architecture perspective, you can recognize that this database does not belong to any one of those other applications. This database is, in and of itself, a software system. And because of the history, for better or for worse, it is its own independent software system, and 10 other applications have integrated with it over a public API. And unfortunately, the public API that has been used to integrate with this software system that is just a SQL Server database, that API is the connection string and T-SQL and maybe calling stored procedures. But regardless, when you recognize that it is a standalone system and it's all manual right now and you need to build a pipeline, you can build up a build and deployment pipeline for that software system that is only a SQL Server database, because you're not going to bundle it with any one of those other 10 applications. And so recognizing that it is architecturally a software system, then you can build a pipeline for it. And now that you've automated it and reduced your cycle time when working with it, you can then talk as a team and ask yourself if you want to start making any architectural transitions now that you have the ability to actually make changes in a reliable way. All right, so I think we will wrap up. We have an offer for anyone here on the webinar, and it's free. If you have an existing implementation of Octopus Deploy, whether you've been using it for a while or whether you have an implementation just of the trial, we'd be happy to provide a free 30-point inspection of your current Octopus Deploy pipeline in your environment for whatever you have, for whatever application you happen to have configured. And our hope is that we can help you have a successful implementation of a fully automated DevOps pipeline with the deployments powered by Octopus Deploy.
Okay, thanks everybody. We'll see you on Slack.
All right. Thanks, Paul. Have a great day.